but much more efficiently with NumPy. We also talked about how we can create NumPy arrays and different operations that we can do over our NumPy arrays. In this lecture, we'll continue the hands-on implementation on NumPy. So let's set the agenda for this session. So in this session, we'll discuss different inbuilt functions that we have in NumPy and what kind of operations we can do with those functions. We'll see how we can concatenate NumPy arrays. We'll also see how we can deal with random numbers using NumPy. Then we'll talk about conditional indexing. We'll talk about how we can index our NumPy arrays and we can put some conditions to filter out data from our NumPy arrays. Finally, we talk about the slicing in multidimensional arrays, how we can slice a multidimensional NumPy array. So without further delay, let's dive into the lecture. Now let's discuss about the different functions that are present in NumPy module and how we can use them. So let's first initialize this NumPy array 2, 4, 3, 6, 5, 8, 7, 9, 1, 0. As we can see that this array is unsorted, right? This is not ordered. So we can use sort function to order this array in the ascending order. Let's see. It has sorted all the elements in ascending order. Now, previously we have seen how we can square each and every element of the NumPy array. We can just do a double asterisk 2, which will square each element, right? We can also achieve that using square function. So np.square and will provide the array. This will square each and every element. Let's see the results of this. So here we can see we got identical results. So np.square will also square each and every element and it will return the array, right? We can also do the square root using sqrt function. So np.sqrt, and if we provide an array s, it will provide the square root of each and every element in that particular NumPy array. So we got 0, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 3 is 9, and so on, right? We need not even provide a NumPy array. We can just provide a single integer as well, and it will do the square root of that integer and return the results like this, right? So all these functions can be performed over integer values or even NumPy arrays. Now let's see what if I provide np.sqrt and I provided a list here. I provide 4, 9. Let's see the output of this particular code. We got 2, 3. So we can also perform all these functions over list as well, right? Now let's initialize another array, which is this one, and we can use cbrt function, which will be the cube root of all the elements. So it will take up all the elements and provide us the cube root of those elements. We got 2, 3, 4 because cube root of 8 is 2, cube root of 27 is 3, and cube root of 64 is 4, right? Then we can use abs function. This will provide us the absolute value of all the elements in the given list. So here I'm providing the list of numbers, which are -1, 2, 3, -5, -6. It will return the absolute value, which is the positive value for all these numbers. So 1 is converted into 1, 2 is converted into 2, -5 is also converted into 5, -6 is converted into 6, and all the positive values from the initial array are returned, right? We can also perform this on integer. So abs -8 will give us 8. We can also perform addition, subtraction, multiplication operation by providing arrays or list to these functions. So np.add function will add the two data structures that are present in the parameters. In the parameters are given two lists and it has added them and provided the resultant list 5, 7, 9. So 1 plus 4 will be 5, 2 plus 5, 7, 3 plus 6, 9, right? We can also perform subtraction like this and it returns 4 minus 1, 3, 5 minus 2, 3, 6 minus 3, 3, right? Then we can also use the multiply function to multiply the elements based on the indexes. Okay. So 1 into 2 will be 2, 2 into 3, 6, 3 into 4, 12. Now let's initialize these two arrays. Now let's understand these functions. np.maximum. It will take up these two arrays and let's see what it returns. It returns the maximum element based on the indexes. So at index 0, I have 2 in the first list and 3 in the second list, right? So out of 2 and 3, which one is greater? 3 is greater, right? So we'll have 3 here. Out of 4 and 1, which one is greater? We got 4. 4 and 2, again we got 4 here. 5 and 1 will get 5 because 5 is greater. 6 and 3 will again get 6. 6 and 5 will again get 6. Similarly, we can also use minimum function, which will return the minimum value at each index. We out of 2 and 3, we got 2 because 2 is smaller than 3. Out of 4 and 1, we got 1, and so on. Now let's check what greater function. So np.greater will perform this operation. If I have list a1, I'm performing if a1 is greater than a2. This is the same operation we can use greater for. Let's see the output of this as well. We can validate all of these are same. So it is performing the operation greater between these two. It is performing a1 greater than a2, and it will compare each and every element. And if the condition is true, it will return true. Otherwise, it will return a false, and we'll get a Boolean array. Then, similar to greater, we have less function as well. It will perform a1 less than a2, and wherever the condition is true, we'll get trues. Otherwise, we'll get false. Now, let's create one more NumPy array with np.arrange21, which will arrange numbers from 0 to 20. Now, np.mean will calculate the average value of the given set of numbers. We have learned measures of central tendencies, right? So we can use np.mean to get the mean value of our data. Here we got 10, which is the sum of all terms divided by 21, right? We can also provide a list to this function, and we can ask for the average value of that list. This gives 5.0. It will be the average of all these numbers, right? We can also get variance using var function. np.var will calculate the variance in this particular set of numbers. Let's see. The variance for this particular list of numbers is 6.66. We can also calculate the standard deviation using std function. This will generate the standard deviation for the given list. Standard deviation for this will 2.58. Similarly, we have a function median, which will calculate the median value. Let's see. We can also refer to these functions directly by the name of our NumPy array. So a1 is my NumPy array. I can use a1.mean, which will calculate the mean value for my array. a1.variance will calculate the variance of my array, and a1.standard deviation will give me the standard deviation in my array. Now let's arrange one more array from 1 to 11. So it will have numbers from 1 to 10. Now there is something called cumulative sum. So this sum function is used to perform that operation. Cumulative sum is the sum till current element. So my first element is 1. Sum of all the elements till this element is 1, right? If I get to 2, now sum of 2 plus 1 will be 3, right? So in the second index, I'll get 3. If I go till 3, I'll get the sum of all these three numbers, 1, 2, and 3, which will be 6. So let's see what cumulative sum represents. It returns the array, and it returns the cumulative sum at a given index, right? Till 4, we'll get the sum of all these numbers will be 10. Now we can also do cumulative product as well using cumprod function, and this will do the product of all these elements. So if I'm going till 5, I'll get the product of all these numbers, which will be nothing but 5 factorial in this case, which is 120. Yeah. Now let's check our array again. This is our array. We have numbers from 1 to 10. Let's check the minimum value. So we can check the minimum value using a.min function. And this will return the minimum value in our data. Similarly, a.max will return the maximum value, and a.sum will sum up all the elements and return the sum of these numbers, right? Now let's arrange one more array using np.arrange64, which will arrange numbers from 0 to 63 and will reshape it to 8 by 8 matrix. So this is the array we have 0 to 63, and we have 8 rows and 8 columns. Let's check the shape of this as well. We got 8 comma 8. Let's check the mean value. So mean value is 31, right? Mean value is 31.5. Let's check mean on the axis 0. So what does this represent? This represents the mean values across the rows. So mean value of all these numbers 0, 8, 16, 24, 32, 48, and 56. So at a given index or at a given column, I'm calculating the average values. So for column 1, the average value is 28. For column 2, the average value is 29. Similarly, for all these indexes, we got the average value using a.mean, and we provided axis as a parameter. By default, it will pick out all the elements and will calculate the mean value. Now let's see what it will do if we provide axis is equal to 1. So now what it is doing is it is calculating the average value of this particular list. So average value of this list is 3.5. Average value of this list is 11.5. So it is calculating averages for a given row, right? So one represents, let's write it here. Axis is equal to 1 represents row wise average, while axis is equal to 0 represents column wise average, right? Now let's check the standard deviation of our data, which is 18.4. And we can also check standard deviations for rows and columns separately as well. So this will do, again, this will do column wise standard deviation. Let's run this. We got column wise standard deviations. Let's do row wise standard deviation as well. We got this. So if you see a common trend here, since if we go column wise, in column 1, we can see the values are very far apart. Hence, the standard deviation is also high. But if we go row wise, we are going from 0, 1, 2, 3, 4, 5, 6, 7. Here, we are not having much diverse or much dispersed data. That's why standard deviation is also low. Now let's check the max value of our data, which will be 63. And we can check max values across the axis as well, where 0 represents column-wise max values and 1 represents row-wise max values. Now let's initialize one more NumPy array, 10, 30, 80, 20, 40. So using np.arg max, and if you provide x, it returns the index of maximum element. Let's run this. So the index of maximum element, it returns 2. Let's see, 0, 1, 2. We got to 80. 80 is the maximum element in this array. So we got 2. We can also check the index of the minimum element by using arg min. And this will return the index of the minimum element, which will be 0 because 10 is the minimum element. Let's create one more NumPy array. Let's check the index of the maximum element. So the index of the maximum element is 9 here, right? Now let's see what does 9 represents here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So at index 9, we have 10, which is the maximum element, which is correct. But we have seen what we have done here is we have reshaped our array, right? We have reshaped it into a matrix of 3, 4 or 3 into 4. But still, we are able to access or we are able to get the index based on the default indexes as well. So NumPy also maintains the default order even though we have reshaped. So if you see here, 2 is still the first element. So it will be at index 0, 1 will be at 1, 5 will be at 3, 5 will be at 2, 4 will be at 3, and so on. And 10 will come at the ninth index, which is the index of the maximum element. Then we can also do axis-wise maximum elements. So if we provide axis is equal to 0, it will check column-wise maximum elements. So in this particular column, the index of the maximum element, it is returned as 1, which means 0, 1, it will be 3. Since 3 is equal to 3, it will take the first occurrence of that particular number, right? Similarly, we can see in the second column, it has returned 2, which is 0, 1, 2. So this number. Column wise, this is the third element, so index will be 2. Let's check row wise maximum element indexes as well. We got 2 comma 3 comma 1. So in the first row at index 2 we have the maximum element 0 1 2. We have 5 which is greater than other three numbers. Similarly, we can use argmin function as well, and we can calculate row and column wise minimum value indexes. So it will return the indexes of the minimum numbers for each and every row and columns. Now let's have a look at our ND array. We have 3 by 4 matrix with values as 2, 1, 5, 4 and so on, right? So this is our matrix. Let's see what rebel function will do. If I provide a matrix to a rebel function, it will generate or it will convert the matrix into a single dimensional array. Let's see if we perform this operation on A1. So it has returned all the elements in form of single dimensional array, and it is going row wise each column values. So it will go to first row, it will pick out 2, 1, 5, 4, 2, 1, 5, 4. Right? Then it will go to second row, it will pick out from the first element 3, 5, 6, 7, and so on. Right? Now let's see what happens if I reshape this array. I reshaped it into two-dimensional array where I only have one row and 12 columns. Right? This is a 2D array. Now let's check the dimensions as well. This is a 2D array and this is the shape. Now let's see what squeeze function will do. Squeeze function will take the array and it will remove the extra dimension from our array. So here one is the extra dimension because we don't need it, right? It's only one dimensional array. We can just have one dimension as well. We can just remove that extra dimension and we got a one dimensional NumPy array. We can check the shape. Let's say I reshaped my array into 3 into 4 into 1 matrix. Now this will represent a 3D array, right? This will represent a 3D array because these have 3 dimensions. Here one is extra, right? We don't need this dimension. So we can just use squeeze function again and it will reduce the extra dimension, right? We can again check the shape, which is 3, 4. Now let's see what linspace function will do. Linspace function is used to generate numbers within a specified range and it will generate n number of numbers. So here I'm specifying I need 5 numbers. So the third argument is the number of elements we want. And this represents our range. So between 1 and 10, I want 5 elements. Let's run this. Let's see what it represents. So it has returned this array where the first element is 1 and the last element is 10. And it has generated 3 more elements to match the count of 5, right? 3 more elements in between. Now all of these elements will have same intervals. So if I add 2.25 to 1, we'll get 3.25. If I add 2.25 to 3.25, I'll get 5.5. Again, if I add 2.25 more, I'll get 7.75. And after adding one more time, we'll get to 10. So between 1 and 10, it generated 5 numbers. Now let's see if I provided 6. Now it has generated 6 numbers with equal intervals within the given range. You can also have large number of numbers. So between 1 and 10, I need to generate 100 numbers. Now let's see. It has generated 100 numbers within the given range. So this is how we can use linspace to generate elements within a given range with the given number of elements, right? Now let's see what np.empty does. So previously we have discussed about np.zeros, which creates a numpy array of all values to be 0, right? It initializes all the values with 0. np.empty will return an uninitialized array. That means all the values in that particular array will be uninitialized so that they will have random values. As you can see here, I'm generating a 2, 3 matrix and it has returned some random numbers, right? It has generated the matrix with the given dimensions and data type is also integer, but these values, these are random values. So basically, when we create a numpy array, it automatically refers to certain memory location. And when we are using empty, so whatever location it is referring, it won't initialize any value. So whatever value was already present at that particular location, it will pick out that value. That is what we can see here. If we run it again, these values have changed, right? Now let's see some of the advanced functions of NumPy. So from NumPy library, we can import these three modules, which are determinant, inverse, and eigenvalues and eigenvectors. So let's say this is my NumPy array, np.array. Let's create this array, and we have reshaped it into a 4 by 4 matrix. So this is a 4 into 4 matrix. So DETA, which is determinant of A, will return the determinant of the given matrix, which is 527. Okay. Inverse of A or INV of A will return the inverse of our matrix. So this matrix, if we multiply this with the initial metric, we'll get identity, right? And finally, EIG, which represents the eigenvalues and eigenvectors of our array. It represents the eigenvalues and eigenvectors. So these are the eigenvalues for each and every column, and these are the eigenvectors. So eigenvectors is a matrix, right? You can use this as well to get only the eigenvalues from a matrix, right? We can also use eigenvectors to get the array of eigenvectors, which is this, right? Now let's understand the concatenation function, which is used to concatenate two NumPy arrays. So let's arrange these two arrays. np.arrange, it will arrange numbers from 0 to 4, and this will arrange number from 5 to 9, right? 10 minus 1. So now we are using np.concatenate a1 comma a2. Let's see what this will do. So this has returned an array where all these numbers are joined. Let's see individual arrays as well. So a1 represents these numbers, and a2 represents these numbers. So a resultant array will have the concatenation of these two NumPy arrays. 0, 1, 2, 3, 4 and 5, 6, 7, 8, 9 are appended at the last. Now let's check how we can do this with matrix as well. So we have created two matrix. This is the first matrix and this is the second matrix. Now let's use the concatenation. So it has generated another matrix where these rows or the rows from the second matrix are appended at the bottom, these four, right? We can specify the accesses as well if we want to do column wise concatenation or row wise concatenation. So if you see here, I have specified I want to do row wise concatenation by providing access equal to 0. So it has picked out all the rows and it has appended them towards the bottom, right? If I provide access is equal to 1, it will do column wise concatenation where all the new values are concatenated here. Here we can see 0, 1, 2, 3, 0, 1, 2, 12, 13, 14. So these are the values from the second array. All of these are appended on the right side. Now let's check what this will do. A1 is equal to A, A2 is equal to, we are providing it a transpose. So A2 will have the transpose of A and A1 will have the matrix A. We can see here as well. Now let's do the concatenation across rows and across columns, right? It has concatenated these two matrices. So this is all regarding functions in NumPy. Let's have a small recap of this section. So we started out by discussing some common functions that are used for mathematical operations like square, square root. We have add, subtract, multiply, minimum, maximum, greater, less, right? These are mathematical operations we can perform using NumPy. Then we saw some central tendencies over our data. We can use mean, variance, standard deviation. We can also use median and mode function to get the central tendencies, and we can also get standard deviation and variance directly using NumPy. We can also get the cumulative sum and product of our NumPy array. Then we also saw these functions min and max, which will return the minimum and the maximum value of our data. Then we talked about arg max and arg min, which will give us the index of minimum and the maximum element in our array, right? Then we talked about Ravel, which will convert our multi-dimensional array into a single dimensional array. And then we talked about squeeze, which will remove the extra dimension from our NumPy array. Then we talked about linspace, which helps us to create a NumPy array within a given range with a specified number of elements. So let's say I want to create 100 elements from 1 to 10. So it will generate 100 elements with equal intervals, right? Then we talked about empty, which creates an uninitialized array. So all the values will be the default values present at that particular memory location which this array is referring, right? Then we talked about some matrix operations like determinant, inverse, and eigenvalues and eigenvectors. We can use these three functions, det to get the determinant, inv to get the inverse of our matrix, and eig to get the eigenvalues and eigenvectors. And we can specify which value we want. Then we talked about how we can concatenate multiple NumPy arrays using concatenate function. We can also do it based on certain accesses as well. Now let's see some of the operations that we can do over random numbers in NumPy. So we can use np.random.randint and we can provide the range. Here I'm providing 1, 10, which means my start will be 1 and my end will be 10. So it will generate a random integer within the given range. Let's see. It has generated 4, right? Let's run it again. It has generated a random integer 6, which is within this range, right? Now let's see what this will do. Now it has generated 23. So this code will generate a random integer from 0 to 50. Now we can also specify the number of integers we want. If we use np.random.randint 1, 100, so this is my range, and I want 10 integers in this range. So it will return an array of 10 random integers within the given range. I can also provide the dimensions. So here I'm providing 10, 10. I need start from 11 and till 100, and it should generate a 10 by 10 matrix, which will be 100 elements in total, right? So it will generate a 10 into 10 matrix of all the random numbers within the given range. Now let's discuss rand and random function. So np.random.rand, this will generate random numbers within 0 to 1. I have specified 10, so it means I need 10 random numbers from 0 to 1. So it has generated 10 random numbers, right? By default, the range is 0 to 1. Now let's see what np.random.random will do. So the only difference between these two functions is this will return a normally distributed data. So let's run this np.random.random, and it has returned this particular array. Now the consideration is the variance of this particular array will always be 1 and the mean will always be 0. This is what a normal distribution will look like. A normal distribution or a Gaussian distribution will have variance as 1 and mean value to be 0. We'll discuss normal distribution in the upcoming lectures when we discuss about probability. Now let's see how we can generate a matrix using this. Here I'm specifying I need a matrix of 3 by 4. Let's run this. It has generated a 3 by 4 matrix, which will have a normal distribution. Now, let's see some conditional indexing in NumPy. So let's generate random integers from 11 to 100, and we want it in a 8 by 8 matrix. So we got this matrix. Now, let's say I want to check what all elements are greater than 50. I can just simply do a greater than 50, and this will give me a matrix of true and false, right? Now, this true and false matrix can be provided as input to the original matrix, and let's see what this will do. So this has picked out a one-dimensional array with all the elements which have true here, right? So a greater than 50 checked. If 19 is greater than 50, it is false, right? If 58 is greater than 50, it is true. For all the true values, it has picked out the value on that particular index. Wherever there was a true, it picked out those values into a one-dimensional array. 58 is coming here. 75 is also coming. 65 also came. This way we can use the Boolean array, Boolean NumPy array, and provide it as an input to the original array. It will pick out all the true records. Wherever the Boolean value is true, it will pick out those elements. Let's check this as well. Here we are checking a smaller than 50. So it picked out the remaining elements, right? We can also check like this. A is smaller than equal to 40 and it picked out all these elements. And we can also check where a equals 16. So there is not a single 16 in our array, hence we didn't get 16. We didn't get anything in the results. Now finally, let's talk about some of the slicing techniques in multidimensional arrays. So let's create one NumPy array with 12 rows and 12 columns, and it will have values from 10 to 100, right? Now we can simply do 0 colon 5, which will pick out the first 5 rows of our data. So this will pick out these 5 rows. Let's check. Yeah, so this has picked out the first 5 rows. If we do 6 colon 11, it will pick out rows from 6 to 10 index from the rows, right? From here till here. Let's check. So yeah, it picked out these 5 rows. Now we can also do reverse indexing. With reverse indexing, we'll first refer the row. So I want -6 rows. -6 row will be, this will be -1. So -2, -3, -4, -5, and -6. My start will be this row. And my end is -1. So end is -1, which is this one. So we won't go till end, right? We'll go till end -1. So we'll pick out these 4 rows. Let's check this as well. Yeah. So we get these 4 rows. Now, if we want to index for both rows and columns, we can just give 2 slices like this, where the first slice will refer to the row. So I want rows from 0th index to the 5th index, 6 minus 1, right? And I want columns from 0 till 4, which means first 4 columns. So let's see, first 6 rows and first 4 columns will get this array, which is this one. Right? We can also specify the step at each slicing. So in the first slice, I'm referring to the rows. I will start from the second row. I'll go till the 8th row, and my step is 2. So I'll skip 1 row at a time. Here, for columns, I'm starting from column number 4, because the index is 3, and I'm going till 7, right? So column index is 3, and we'll go till 7, and my step is 2. Let's see, this gives us a smaller array where we have skipped 1 row and 1 column within the given slicing range. We can also do reverse indexing with this as well. We can start from the 10th index of the rows. We'll go till 3, and our step is -1. And we are picking out columns from 5 to 10. Let's see this as well. This represents this array. Now let's see one real life example where we can use NumPy. So here I want to compare these 2 students. We are taking the marks of these 2 students in 5 subjects as input, and we'll calculate the absolute difference in their marks. So here I'm taking input of 2 lists, and I'm converting those 2 lists into NumPy arrays. Then I'll check the absolute difference. Let's see. Let's say these are the marks of student 1, 20, 30, 45, 22, and 50. These are marks out of 50. And marks for student 2 are 40, 43, 25, 30, and 10. So these are the marks. And in the array, we got the absolute difference of the marks for each subject of these 2 students. So for subject 1, student 1 has scored 20 marks and student 2 has scored 40 marks. So we got 20, which is the difference between these two scores, right? 40 minus 20 or 20 minus 40 will take the absolute value, which will be 20. Now, the first student has scored 30 marks and the second student has scored 43 marks in the second subject. So we'll get the absolute difference to be 13. Similarly, we got the absolute difference for all the subjects for these two students. This is all regarding NumPy. Let's just have a quick recap of what we have covered in this session. So we first discussed that NumPy is a short for numerical Python, and it is a package used for numerical computing in Python. Then we talked about how we can create ND arrays. We talked about different ways of creating ND arrays. We can create it from an object. We can typecast also using as type, right? Then we can create ND arrays by specifying a range as well. Then we talked about special arrays, which are arrays of ones, zeros, and creating ND array of a specified value. So we can use np.full for that. Then we talked about how we can create an identity metric. We can use np.I function, right? Then we talked about different operations we can do over ND arrays. We talked about addition, subtraction, all these mathematical operations we can do. Then we talked about some conditional operations, like comparing the values of the two NumPy arrays. Then we talked about different indexing and slicing techniques for ND arrays. And we talked about how we can reshape and transpose these arrays. Finally, we talked about some important NumPy functions. So some of the mathematical functions that are there: squares, square root, absolute values, subtract, multiply, maximum, minimum, all these functions are used to calculate or to perform mathematical operations like greater than, less than. Then we talked about some of the functions related to measures of central tendency and dispersion. So we can calculate mean, median, mode. We can also calculate standard deviation, variance in our data. We can also calculate cumulative sum and cumulative product using NumPy. Then we talked about min, max, and sum function, which will give the minimum, maximum, and sum of all the elements in our array. Then we talked about some special functions which helps us to get or to perform linear algebra over our matrix. We can use the ET function, which will get the determinant of our matrix. We can use INV, which will get the inverse of our matrix. And we can use EIG, which will get the eigenvalues and eigenvectors for our matrix. Then we checked how we can concatenate two NumPy arrays. Then we also checked how we can concatenate based on axis. So we need to concatenate over the rows or the columns. We can specify that as well with the concatenate function. Finally, we talked about some random numbers. So there are two major functions, randint and rand, which are used to generate random values. And randn will generate a normally distributed NumPy array, right? Then we talked about conditional indexing, which helps us to refer elements based on certain conditions, which satisfy a certain conditions. Then we talked about slicing techniques in multidimensional arrays. So there we can use normal slicing. We can also provide comma separated slicing for rows and columns based on the number of dimensions we have. And we can also perform reverse indexing. Finally, we saw an example where we are comparing the absolute marks of two students across all the subjects, right? That will be all for the part 2 of NumPy. Let's talk about the key takeaways of this session. So in this session, we talked about different NumPy functions that we have to perform mathematical operations, right? Also, to perform descriptive statistics, we have functions like mean, median, standard deviation, and variance, right? STD for standard deviation, VAR for variance. Then we talked about how we can concatenate different NumPy arrays and how we can deal with random numbers using NumPy. Then we talked about how we can filter out data using conditional indexing, and we talked about how we can slice the data in a multidimensional NumPy array. Now from the next session, we'll start a new library that is pandas. Till then, keep on practicing. And if you like the video, please do provide the feedback. Thank you for joining this session. All the best for your preparation. Happy learning.